The reason why we did so many lessons where we used models and we used different strategies to solve these things, these multiplication problems, is because now, once we get to the pencil and paper way, it should be like that. Because a lot of people get to multiplication and they get scared. But now you've seen why the answers are what they are when we use the base 10 blocks. You've seen different strategies like the area models and distributive property, which are the same thing, just one has a model with it, one is just solving it using distributive property. Well, now, today's lesson, we're going to solve multi-digit multiplication the pencil and paper way. So we won't be doing models except to check, or different strategies except to check the answers. Does everybody understand? Good. So, let's go ahead and look at page 241. So everybody go ahead and open your book to page 241. Zari, can you tilt your camera down just a teeny tiny bit? I still want to see your face. There you go. That should be good. Perfect. Okay. Now, the sentence under the title. Go ahead and read it, Michaela. A little louder. We can't hear you.
Zach bought 13
The sentence under the title.
basic 10 blocks can be used to multiply two-digit numbers.
So we know that. We know base 10 blocks can be used to multiply two-digit numbers. We've used them twice in two different lessons. We used them where we didn't have to regroup, where however many ones was the number of ones in our answer, and the number of tens was the number of tens in our answer. We used them with regrouping, where sometimes we had to trade out 10 ones for one one. Sometimes we had to trade out 10 ones for one what, Carla?
100.
Did we trade 10 ones for 100, Carla? We traded 10 ones for one what, Cullen?
1 10 rod.
One 10 rod. And sometimes we had to trade out 10 tens for one what? Victoria? 100s flat. Sometimes we had to trade 20 tens for what? Zari?
2 10 rods.
Sometimes.
200s.
Good. 200s flats. And sometimes we had to trade 21s for what? Smith?
For 2 10 rods.
For 2 10 rods. Maybe not in today's lesson, but maybe in today's lesson, and most likely in tomorrow's lesson, there are times where we might have to trade 7 tens. What would you trade? 70 tens. What would you trade 70 tens for, do you think? Kingston? 700s flats. Good. What if I had to trade 90 ones? What do you think I would trade them for? If I had to trade 90 ones, what would I trade them for, Aaron? 90 ones would be the same as 90 tens? Zadie?
You trade them for 9 10.
I would trade them for 9 tens because remember, 90 ones has 9 tens in it. Because 9 ones times 10 is 90. So there will be times, there will never be a time where you're going to have to trade 100 ones or 100 tens. You'll see an example either later today or maybe tomorrow. You'll definitely see examples of this in lesson 9, which hopefully we will get to tomorrow. There is a chance we won't get to it till Monday though, because when the sub's here, you're not going to do a new lesson. Remember, my friend is getting married on Saturday, so Friday I'll be off helping her get ready. And I'm not gonna have you do a new math lesson with the sub, so don't worry about that. you'll do review. You'll basically get a study guide that you can use for your test that you can start on Friday. Okay. Unless something happens. Because if we have to do 2 days of tomorrow's lesson, then you'll finish it on Friday. Otherwise, you'll get a study guide. Okay, everybody, finger or pencil on example 1. When I see everybody's finger or pencil on example 1, I will continue. Okay, read in your head out loud. I'm sorry, read in your head while I read out loud. Okay, Zach bought 13 packages of light bulbs. There are 4 light bulbs in each package. How many light bulbs are there in all? Well, first I find my question, or my command, because do we always have a question mark? Sometimes we have a period at the end, but it's telling us what to do. That's a command, remember. So, how many light bulbs are there in all? Well, I know once I find the question, the first thing I do is find my answer unit. I see how many. I see the word light bulbs. So I know light bulbs is my answer unit. I also notice that in my question, I see in all. In all almost always tells me that my answer is going to be greater. Almost always. So I already have a good idea that this question is going to have me add or multiply. I don't know which one yet, but in all almost always means that my answer is going to be bigger. The operations that lead me to a bigger answer are addition and multiplication. I have to look at the rest of the problem to figure out, am I adding or am I multiplying? Let's go back and reread the rest of the problem to find more important information. Zach bought 13 packages of light bulbs. Well, I do see the word light bulb, but am I talking about 13 light bulbs? No, I'm talking about 13 packages. I don't know anything about packages yet, so do I know if that's important yet? No. So let's go to the next sentence. There are 4 light bulbs in each package. Well, now I do see a number of light bulbs. So I know 4 light bulbs is going to be part of my equation. I also see each, which tells me to multiply or divide. Well, I already know from a different part of my problem I was either adding or multiplying. Now I know from this part, each, I knew from in all I was either adding or multiplying. Now I know from each that I'm multiplying or dividing, which operation means both each and in all. Kingston? Multiplication. So I know I'm going to be multiplying, because multiplying works for both in all and each. Adding only works for in all. Dividing only works for each. So it can't be either one of those. Multiplying works for each and in all. So I know it has to be multiplying. And then I know whatever comes after each, in this case the word package, is my other unit. I remember in the first sentence it said Zach bought 13 packages of light bulbs. Now I know for sure package is my other unit. So I know now that 13 packages is going to be part of my equation. Now I'm going to check just to make sure that I am 100% multiplying and I didn't make a silly mistake somewhere. If I have 13 packages and each package has 4 light bulbs in it, am I going to end up with a larger number of light bulbs or a smaller number of light bulbs? Carla?
Bigger.
Bigger. So now I know, yep, I was right, I am multiplying. But I always want to check. Even if I think I'm 100% right, does it hurt to check one more time? No, never. It never, ever, ever hurts to check. Because sometimes you might be 100% right, but you read the problem wrong. So you got the right answer to the wrong problem. So that's why even if we think we're 100% right, we still go back and check. So So now we know we have 13 packages, there's 4 light bulbs in each. We want to find the total number of light bulbs. So we know our problem looks like 4 times 13. We know with base 10 blocks, if we're going to model, do we model 4 or do we model 13 with the base 10 blocks? Mason? 13. We model the larger factor. What does 13 look like in base 10 blocks? Without looking. 1 10 rod, 3 ones cubes. Very good. The smaller factor tells me to do what, Mason?
Repeat that 4 times.
Repeat it that many times. So we have our model of 4 times 13. We have 13 repeated 1, 2, 3, 4 times. With base 10 blocks, we know we count the ones first. So let's count the ones together. Use your finger, look in your book or the tip of your pencil, but keep up with me. So as I count, you move your pencil or your finger to the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know that I can't put 12 in my ones place, so I regrouped my 12 ones as 1 10 and 2 ones. Now this is what it looks like when we do the paper and pencil way. I'm looking at my ones. I have 3 times 4 in my ones place. I know 3 times 4 is 12. Well, I'm in the ones place, so I can go ahead and put that 2 in the answer, in the product. But I need to regroup that 110. So I'm going to regroup that 110 to the tens place. Now this is where things may not go as you expect. Because when we get to the next step, where we multiply the tens, we already know the 1-digit number gets multiplied by the ones and the tens, right? We already know that. We know that from lesson, was it like 5 or 6? 5. We know that we multiply that 1-digit factor by the digit in the ones place and the digit in the tens place. But now we have this extra 10 that we have to keep in mind. When we have a regrouped number in a multiplication problem, we do not multiply that regrouped number. We add it. So we multiply the tens. 4 times 1 equals 4. But then we have to add the regrouped 10. So instead of taking 4 times 1 and then multiplying by 1 again, we are going to multiply 4 times 1 and then add 1. So 4 times 1 is 4, plus 1 is 5. Finish writing, then pay attention because I'm going to show you why we add instead of multiply by that regrouped number. So write that answer, write that 5. And now let's look at this model. We know we already have 2 ones. We're done with these 2 ones in this model, right? Because we've got them right here in the ones place. Well, now we have to count the tens that were there originally because 4 times 1 is 1, 2, 3, 4. But we had to add another one when we regrouped. So we multiply 4 times 1, 1, 2, 3, 4, and then we add that regrouped 10. So this regrouped 10 is this one that we add. So whenever you have a regrouped number in multiplication, do you multiply it? Show me, don't tell me. Whenever you have a regrouped number in multiplication, do you multiply it? Do you add it? Show me, don't tell me. Yes. So you just have to remember, multiply as usual, any regrouped number gets added. because when you're counting your base 10 blocks, you're not multiplying by that extra 10. Did we ever multiply by the extra 10 when we regrouped? No, we added it in to what we already had. We already had these 1, 2, oops, my fingers are off. 1, 2, 3, 4 tens. We already had those in our very first model. But then because we had to regroup, we're adding in, literally adding in, not putting. We are literally adding in an extra 10. I think you understand that. Does that make sense? Does that make sense why we don't multiply this extra 10 rod? Multiplying just means we're taking an amount of objects and we're repeating it a certain number of times. We're not taking 4 objects and 13 objects and putting them together. But here we had to add an extra object. So we are adding it, not multiplying. So that means, class, 4 times 13 equals what?
52.
52.
52.
So, how many light bulbs does Zach have in all? Class?
52 light bulbs.
52 light bulbs. Let's add our unit because they didn't do that, and that is not what we do. The reason I have you always put put the units is because I want to make sure that you're reading the problem correctly. The biggest part of word problems is reading the problem correctly. The math is not the biggest part. You just have to read the problem correctly so you know what math you're actually doing. So that's why I want you to put the unit, because it shows me that you are reading the problem correctly. Okay, now let's check using the distributive property. So we know the first step to using distributive property is to do what? Smith.
Break apart the larger factor.
So what is that math vocabulary word that means break apart?
Decompose.
Decompose. Good. And we're decomposing the larger factor into what other math vocabulary word? We're decomposing the larger factor into what other old math vocabulary word that we learned a long time ago? Cullen.
Expanded form.
Expanded form. So Smith, what does 13 look like in expanded form?
10 plus 3.
10 plus 3. Thank you. Now what do? We've got our larger factor in expanded form. What do we do next? Carla, do we need to do anything or are we ready to write our equation?
We're ready to write down our equation.
Good. So what does that equation look like?
It will have a...
Don't forget to tell me symbols.
It will have a apostrophe,
Parentheses.
parentheses, 4 times 10.
4 times 10 because we take the smaller factor and multiply it by each piece of the larger factor. Okay, so Carla, we have 4 times 10. What comes after 10?
We put the answer problem with our apostrophe
Parentheses.
at the 10.
Parentheses, Carla.
Parentheses.
Okay, then what?
Write down our 10.
We already did that. We did 4
I mean,
times
write
10.
our 10.
So Carla, look, we have parentheses, 4 times 10 parentheses. What comes next?
Plus
Good,
parentheses,
good,
4
good,
times
good.
3 parentheses.
Very good, because we're taking our smaller factor 4 and we're multiplying it by both pieces of the larger factor, the 10s, which in this case is 10, and the 1s, which in this case is 3. Very good. So we have parentheses 4 times 10 parentheses plus parentheses 4 times 3 parentheses. Oops. Now what? I forgot. I'm asking for volunteers. Now what? Zari, we multiply the...
You would multiply what you put in the parentheses.
Okay, well, which part do we multiply first? Remember, we multiply the
bigger number.
What do we say? That's not our math vocabulary. Zadie? I multiply the tens. So Zari, the tens is which problem? 4 times 10 or 4 times 3?
4 times 10.
Which equals?
40.
Okay? Now what do? We just multiplied the tens. We brought down the plus sign. Victoria, what do we do next? Tell me the math words.
We multiply 4 times.
What's the math vocabulary way of saying that? Michaela?
We
Multiply
multiply
the ones. Come on, guys. It's a pattern. I'm asking for the same pattern every time because every time we do distributive property, no matter what the problem is, are we going to do 4 times 3? No, but we're always going to multiply the ones. That's why the math vocabulary is so important. So, Victoria, if we multiply the ones, which problem are we doing? 4 times 10 or 4 times 3?
4 times 3.
Which equals?
12.
Now what do? Colin,
Add them up.
what is the math way of saying that? Add the Smith?
Partial product.
Partial products. Make sure you know the math way of saying it. Okay, so if we add the partial products, what are we adding, Cullen?
40 plus 12.
40 plus 12. Are we going to have to regroup in any place?
No.
So we can just go side to side. Add the 1. 0 plus 2.
2.
Add the tens. 4 plus 1.
5.
So our answer is
52.
52. Okay. So that's what it looks like, paper and pencil and base 10. When you're regrouping, you're keeping the ones that stayed behind in the ones place of your product. The regrouped 10 gets put above the tens place. Do you add the regrouped 10 or do you multiply the regrouped 10? Class.
You add it.
You add it. Do we ever multiply anything that has been regrouped? Never. Never, ever, ever in a million years would you ever multiply the regrouped number. Because if I did that, this is what would happen. Okay, I know 4 times 1 is 4, times 1 is 4. And is that correct with our model? Do we have 4 tens and 2 ones? No. Is that correct with our distributive property? Did we get 42? No. That is why you always, always, always add the regrouped 1. Do not multiply it. Do not multiply the regrouped number ever, 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 ever. Smith.
Should we write that in caps on our
Sure.
paper?
Yes, that will be helpful. Do it. I don't know. Let's see. Do it here. Underneath the multiplication problem. Do not go over top of the multiplication. Never. Oops, I forgot my R. Multiply try not to go over top of anything like I am. Regrouped, and don't go over your arrow that points from this 10 to this 10 rod, okay? Never multiply the regrouped number. Exclamation point, exclamation point. Add the regrouped number. So put that, make sure that's in a box. Never, ever, ever multiply the regrouped number. Only add the regrouped number, whether it is a 10, 100, 1,000, 10,000, whatever. When you are ready, go ahead and turn the page. Should be on the next page, page 242. Go ahead and put your finger or pencil on example 2. When I see everybody's finger or pencil on example 2, I will continue. your head while I read out loud. Will makes $6 an hour shampooing dogs at a pet shop. Last month, he worked 38 hours. How much money did Will earn? So we have our question, how much money did Will earn? The first important place I look is after how many or how much. If I only have how much, what do I know is almost always going to be my answer unit? If I only have how much, there's no word after it. Zari?
Most of the time, we are going to be multiplying.
That's not what I'm asking, Zari. Listen to my question. Make sure you're answering the question I'm asking, not a different question. If I only have how much with no word after it, I know that my answer unit is almost always going to be what? Victoria. If I just have how much with no word after it. Money, which is a dollar sign. In this case, I actually have the word money, which I know will be my answer unit, but am I going to write number money as my answer? No. Victoria told us we're going to use a dollar sign. So we know we're looking for an amount of money. The rest of it says how much money did Will earn? Well, there's nothing else in that problem that tells us in that question that tells us anything. So let's go back and reread. Will makes $6 an hour shampooing dogs at a pet shop. Well, I see money, so I know $6 is going to be what I need. But remember, we saw this before. $6 an hour, I don't see each anywhere else, because then I have last month he worked 38 hours. But how do I know what my other answer unit is? If I make $6 an hour, it means the same thing as saying I make $6. Victoria? We had this, it was like a train problem. Michaela? Good. $6 an hour means the same thing as $6 each hour. So that means an hour shows the word and before that word means I am multiplying. Whoops, that's a plus sign. Multiplying or dividing. And it means that the word that comes after hour is our other unit. $6 an hour means the same thing as $6 each hour. It was like that problem with a train where the train went a certain speed, like miles per hour.
Oh, yeah.
It meant the same thing as miles each hour. So I know an hour means I'm multiplying or dividing, and my other unit is hour. So let's keep reading to see if we find a number of hours. Last month he worked 38 hours. So we know we're trying to figure the pieces of our problem of our equation are $6 and 38 hours. Now, if I work for $6 an hour, if Will works for $6 an hour for 38 hours, is he going to end up with more or less than $6? Zari.
He's gonna end up with more.
He's definitely going to end up with more. So we know we are doing multiplication. So we know our problem is 38 hours times $6. A dollar sign is the only unit that we're going to put in our equation. But we do need to make sure that anytime there are dollars, we include it in our equation. That is the only unit that will ever be included in our equation, is a dollar sign. So instead of doing distributive property to check, we're going to estimate to check. Zadie, we have 38 times $6. Which of those factors are we going to round? The larger factor or the smaller factor? The larger factor. So 38. We're going to round it to which place? The tens place. 38 rounded to the nearest 10 is what, Zadie? 40. Because remember, the digit next to the place we're rounding to is 8. 8 is 5 or more, which means we add 1 to the digit in the place we're rounding to. Does our other digit change? Or does our other factor change?
No.
No. So 40 times $6. Using basic facts and patterns. Class, what is 40 times $6? Class?
$240.
Thank you, Colin. $240 because 4 times 6 is 240. We have 1 0 at the end of each of the factors, so 1 0 at the end of the product. Yes,
They forgot the dollar sign.
that's okay. Because
With the
estimating, you don't technically need it, but we're going to get into the habit of always putting it, so we're going to go ahead and put it. Okay, I don't know why I pulled that stick. So now, we're going to do this the same way we did the first example, but without base 10 blocks. So we just have to remember why we're doing what we're doing, which we've done base 10 blocks and models like 14,000 times now. So we should all know exactly why we're doing what we're doing and what it looks like in our heads. So, step 1, multiply the ones. Remember, our 1-digit factor gets multiplied by both the ones place and the tens place. So, step 1, multiply the ones. 8 times 6, without looking, what is 8 times 6, class?
48.
48. Now we know 48 is a 2-digit number. We can't put, don't do this, 48 in the ones place. So that means, just like with all the others, we keep the digit in the ones place, and then we have to regroup the digit in the tens place. So this means we're taking 40 ones cubes, and turning them into what? We're taking 40 ones cubes and turning them into what? Zadie? 4 10 rods. So we have to come above the tens place and put a 4. Because we are adding 4 new 10 rods that weren't there before. So 48 looks like 4 tens. Follow this arrow. Go over that arrow with your pencil so that you can see it better. Our 4 tens get put above the tens place, and our 8 ones stay in the place we are multiplying. So does everybody understand that? Now, step 3, we multiply the tens. We already know our 1-digit factor gets multiplied by both digits in the larger factor. So now we're saying 6 times 3. 6 times 3, without looking in your book, is what, class?
18.
18. But we have this. What do we do with this regrouped number? Victoria. Do we add it or multiply it, Michaela? Add it. So we have 6 times 3, which is 18. Now we have to add our regrouped tens, not multiply our regrouped tens, we add them. So 18 plus 4, well, we can use our fingers to just count up. 18, 19, 20, 21, 22. So we keep this. Do we have a hundredths place to regroup? No. So we just write our problem. We just add that 2 from the 22 into the hundredths place. So class, 38 times 66 is what?
$228.
228, which means Will earned, class?
$228.
$228.
$228. Now our estimated product was $240. Are these pretty close? Close enough to say we're reasonable? Yes. The product, $228, is close to the estimate, $240. Now some of you may be saying, those really aren't that close. So which way of checking do you think will make sure you will know 100% that you are right? Mason? Not division. We don't know how to do that yet. Michaela? Area models or Smith?
Distributive property.
Distributive property. Either one. We know we're doing distributive property with both, but the area model has a model with it, which you may like better. So yes, you can use estimation to check, but remember, sometimes your answers aren't going to be that close. You just have to think, okay, are they within 5 of that next place? Okay. Is everybody ready to move on to the guided practice? Zari, do you have a question?
No, but you know when we were trying, I said that I was checking after it.
Uh-huh.
That is the same way that my mom told me how to check it.
Okay. But remember, we don't want to try to check things with things we have not learned why it is yet. So remember how I said, your parents will try to teach you the quick way. I'm telling you, it happens every year. Your parents are going to try to teach you the quick way before you're ready for it. Just tell them, nope, please don't do that. Please don't confuse me. We are going to learn it. Let me learn it when it is best for my brain, my 9 or 10-year-old brain, to learn it, okay? Because if you try to get things too fast, something's going to get left behind. Something's going to get confused or jumbled up in here. So just tell your parents, I will get to it. Please let me get to it when I get to it. Please don't confuse me by trying to teach me this too soon, okay? There's a reason math books are not just written by random people. They are written by people who know how a 4th grader's mind works. So they know, okay, we don't want to teach this yet because they need to get this concept first. This concept must be in here before we go to the next concept. So that's what can go wrong when you try to do too much too soon, okay? That is why when I learned math, we didn't learn all that extra stuff, and this never made sense to me. Because I didn't learn all that other stuff that told me why. Some kids, this made perfect sense to. But a lot of kids, this didn't make sense to. So that's why I hated math forever and ever and ever. Because I never knew the why, so it never made sense to me. But just teaching 4th grade math, now I know the why. And it all makes so much more sense to me. Even stuff that we don't learn in 4th grade, because the patterns are here too. So that's why, make sure that we're learning the patterns so that when you go to the next grade, we're just building up on these patterns that we learned this year. And then the next grade, we're building up on those patterns and these. And we know why. When we know the why, we can find the patterns, we can figure out the answers, even without necessarily knowing how to do it yet. So please make sure, especially when we get to the next chapter and division, because I've seen it happen where parents try to teach their kids too soon and they miss a step, and then it is so hard to unlearn that missed step. So please, 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 we will get to it. Okay? Yes, Kingston, quickly, because we need to do the guided practice.
On Wednesday, I saw some people like in September.
Mm-hmm.
Every probably was on that.
Yes, and I just said to ignore those problems. If you get the rest of them correct, those problems won't be a big deal. Because there was no way. It's okay. Just, we're moving on. Okay. Everybody, let's go ahead and look at the guided practice. Okay. Let's look at number 1. The directions say multiply, check for reasonableness. So number 1 is 23 times 4. First we're going to estimate. Oops, that's me. Colin, let's estimate first. Which of these factors are we going to estimate? 23 or 4?
23.
23. 23 rounds to what?
20.
20. Does the 4 change?
No.
No. So 20 times 4 using basic facts and patterns is what, Cullen?
80.
80. Now we're ready to multiply. Step 1. Use your steps on example 2. Step 1.
Multiply the ones.
Multiply the ones, which means we're doing what?
Multiplication.
Well, what are we doing? What problem are we doing if we're multiplying the ones? What's the equation?
3 times 4.
3 times 4, because remember our 1-digit number gets multiplied by the digit in the ones place. Okay, Cullen, 3 times 4 is what?
12.
12. Can we write 12 in the ones place?
No.
No. So which digit goes in the ones place?
The 2.
And what do we do with that 1 in the tens place?
We regroup it.
To where?
The tens.
We regroup it to the tens place. Step 3. So we just did step 2, which was where we regrouped. Step 3.
Multiply the tens.
Multiply the tens, which means we're doing what problem?
4 times 2.
4 times 2. So we take our 1-digit factor and we also multiply it by the digit in the tens place. So 4 times 2 is what, Cullen?
8.
8. Do we put an 8 here?
No.
No, because what is step 4?
Step 4 is add the regroup tens.
So we're saying 4 times 2, which is
8.
and then we are,
Adding 1.
which is
9.
9. So that means, Cullen, 23 times 4 is
92.
92. Is that pretty close? Close enough to our estimate? It's close enough. If these digits in the tens place are more than 5 apart, you need to check. Like if they are super far apart, you need to go back and check. Okay, so remember, step 1, multiply the ones, which is 4 times 3. Step 2, regroup if you have to. Step 2, regroup if you have to. Step 3, multiply the tens. That means you take the 1-digit number and you multiply it by the digit in the tens place. Step 4, add the regrouped number. Not multiply it, you add it. Okay, number 2. Actually, you know what? Number 2 in the guided practice, I'm going to let you do on your own. Because I want us to do one of these. Let's do number 6 on the independent practice as our other guided practice problem. Okay? So everybody go ahead and look at number 6. Helper number 1, please sanitize, erase, sanitize. Okay, so for number 6, we have 29 times 4. What do you notice about how this is written right away that we need to fix? Victoria. Sorry. This mask makes my mouth tongue-tied. I know it does. What do you notice about the way 29 times 4 is written that we need to fix right away? We need to write it up and down. Now, you can put your estimate closer down to the bottom. Let's go ahead and add a grid so that we know exactly how much space we have. So right above each number, draw a line, and then right before each number, draw a line so that you know you have this whole box to work with. Make your line close to each number. Okay, Victoria, so let's write this up and down. We're going to write 29, and then we're going to make sure that this 4, this 1-digit factor, is right beneath the ones place. But now we're going to estimate. So Victoria, let's do that first. We can do that like right down here because we can do that sideways, right? Yes. So which factor do we round? 29 or 4? And 29 rounds to? 30. Does the 4 change? No. Okay, notice how I'm doing it right here so that I have lots of space to still solve my problem. 30 times 4 is what, Victoria? 120, not 12. That's what 3 times 4 is, but 30 times 4 is 120. So that means our answer needs to be pretty close to 120. So now let's solve 29 times 4. Victoria, step 1. Tell me the math way in words first, then you can tell me in numbers. Multiply the ones place. Remember, if you can't remember the steps, where are they? Well, tell me. Zadie? Where in your book? Cullen?
On example 2.
Example 2 has the exact steps. So, Victoria, step 1 is multiply the ones, which means we're doing which problem?
9 times 4.
9 times 4, which equals?
36.
36. We know we can't put 36 in the ones place. So which digit in 36 goes in the ones place?
The one.
Which digit? 6. So what has to happen to that other digit? 3.
We put it above the two. I mean the tens.
We move our 3, which stands for 30, above the digit in the tens place. Okay, so that was step 2. Now step 3. So step 2 is to regroup. So we regroup the 3 and 36 to the tens place. What's step 3?
Now we multiply the 10.
We multiply the tens, which means what problem are we doing?
2 times 4.
4 times 2, which equals 8. But does 8 go here?
No.
No, because what do we have to do because of this regrouped number?
We add, not multiply.
Good. We add, not multiply, the regrouped number. So 4 times 2 is,
8.
plus 3 is
11.
11. We don't have a hundredths place to regroup to, so we can put the digit, we can go ahead and put that extra digit in the hundredths place. So Victoria, that means 29 times 4 is
116.
116. Okay, so right now we have about 10 minutes until music. We're going to use all that time to go ahead and start. Yeah, it's Wednesday. So yes, music. We have 10 minutes. Oh, I'm sorry. We have 10 minutes till we need to start reading. Sorry. I got confused. So, we're going to go ahead and start the independent practice, and then after music, I'll let Dr. Nix know that I need you back about 10 minutes early so that you can have 10 more minutes to do to finish the independent practice, and that'll be 20 minutes in all, which is a good amount of time. Okay, now go ahead and keep going. Remember, start with number 20. If you would like, I'm going to do one more problem so you can follow along, or you can go ahead and get started. It is up to you. Yes, Sadie, quickly.
Can I use Russian?
Go quickly, but you're going to miss it. You're going to miss out on time. Okay, number 8. We're going to do number 8. 7 times 36. I'm going to pick one. Smith, would you like to do it with us, or would you like to keep going?
Keep going.
Okay. Kingston, would you like to do it with me, or do you want to keep going? Do it with me. Okay, so Kingston, you're going to help me out. Everybody else, you can tune me out and keep going, but make sure you check. If you need some extra practice, do this with Kingston and I. Okay, so Kingston, what do we need to do first with 7 times $36?
Multiply the 1.
Can we do that sideways? You need to go quickly because we actually only have 5 minutes. So come on. We can't do it that way, so what do we need to do? We need to set it up and down. So that looks like $36. We're going to make sure to include the dollar sign. Remember, if your problem, even if it's not a real world problem, has a dollar sign, you better include the dollar sign. And what do we do with the 7? Does it go under this 3 in the tens place or the 6 in the ones place?
6.
Now, since we're estimating, let's go ahead and estimate. Are we gonna round 7 or $36? $36. $36 rounds to 40. Oh, I need everybody to listen to me for just a second. When you're rewriting a problem up and down, make sure that the larger factor is at the top. It will make it much less confusing for you. Even though 7 comes first, always make sure to put the larger digit at the top. The larger factor at the top. Does everybody understand that? Okay. So Kingston, and then do we do anything to the 7? No. Okay, $40 times 7 equals, using basic facts and patterns. Okay, who knows their basic facts? $40 times 7 is what, Victoria? $280. If you don't know your basic facts, well, even this lesson, even if the process is easy, you're not going to be able to do it. Okay, Kingston. So now we know our answer has to be close to $280. Okay, now let's follow the steps. Step 1. Kingston's going to help me, but you can go ahead and work with us. quickly, but we're going to start reading, which means you may miss out. Should have gone this morning before we started. Kingston, step 1.
Multiply the 1.
Can't hear you.
Multiply the 1.
Which means we're doing which equation?
6 times 7.
6 times 7 is what? Who knows their basic facts and can tell me 6 times 7? Colin.
42.
42. Can we put 42 in the ones place, Kingston? No. Which of those digits, the 4 in the tens place or the 2 in the ones place, goes in the ones place?
2.
The 2. What happens to that 4 in the tens place? What do we do with it?
Put it above the
We, what's that math word? We regroup it to the tens. Which means we write our 4 above the tens place. Okay, so that was step 2. Step 3.
Multiply the 10.
Multiply the tens, which means we're doing what multiplication problem?
Times 7. 3 times 7.
7 times 3. Okay, 7 times 3 is what?
7 times 3.
Somebody who knows their multiplication facts. Aaron? 21. But step 4 is to do what?
Add the
Add the regrouped tens. So that means 7 times 3 is 21, plus 4 is
That's 25.
25. Do we have a hundreds place to regroup to? No, so we can just put that 2 in the hundreds place. What do we need to make sure before we move on? What do we have in our factors that needs to be in our product?
$1
A dollar sign, which means that 7 times $36 is $252. Is that within like 5/10 of 280? Is that within 5/10 of 280? Look at the digits in the tens place. Are they within 5? They're more than 5 digits away. So are they correct? Are we reasonable? Yes. Okay.